Means object is there. Suppose I am consider one object is there. Okay, some object that is one here consider handkerchief is there, and just I am just released from top of the height and just it falls down. Okay, I am simply called this is the free fall. We just this object is called as a free fall, and that object is said to be the freely falling body. And this is free fall due to the gravitational force, because gravitational force acts on this the object. So simple free falls. Look at your student in science. Okay, I'm in all results. Okay, all the sections. Science again means marks in science very poor. Okay, बहुत बुरा लग रहा है वो, इतने बकवास मार्क दिए ना सभी ने साइंस में, कुछ ऐसे ठीक से नहीं लग रहा, तो बहुत कम रिजल्ट लगा है साइंस एज कम्पेयर टू अगेन आल्सो अदर सब्जेक्ट में आपने अच्छे मार्क्स लिया, साइंस में इतने कम मार्क्स। क्या आप स्टडी करते हुए क्या नहीं करते, क्या आपको समझ में नहीं आ रहा। सिंपल ऑब्जेक्टिव में हर एक पॉइंट बोलता हूँ कि हर कौन से पॉइंट में ऑब्जेक्टिव आ सकते हैं, कौन से पॉइंट में है, तो वो थोड़ा सा कॉन्सेंट्रेट करो वहाँ। Let's see here. Free falls. Again, this is questions will be asked in your examination in objective type question. Simple definition is there. What is simply body falling down the earth under the action of the gravitation force. Question is that free fall means object, other or object or any body is freely falling the body due to. Question is that object. Okay, you see two type questions there. Object is said to be freely falling body due to under the actions of, otherwise under the actions of options are there: gravitation force, again any reaction force, normal force, tension force is there. Like that, this like as the questions. This types में question आ सकते हैं. So answer is the gravitational force is there. स्टेटमेंट में आपको सिर्फ आंसर देखना है, एक्चुअली स्टेटमेंट क्या है उसमें से कौन से क्वेश्चंस आ सकते हैं। सिंपल क्वेश्चन क्या है, अ बॉडी इज सेड टू बी फ्रीली फॉलिंग बॉडी। Again options are there: when the body is falling toward the earth under the action of gravitational force. Second option, body is thrown in upward direction in under the action of gravitational force. Again third option, body is thrown in upward direction in the opposite direction of the gravitational force. Otherwise, object is thrown in upward direction in the normal force. इस टाइप में ऑप्शन आ सकते हैं, आपको सिर्फ एक ऑप्शन सेलेक्ट करना है। अब देखो नेक्स्ट क्वेश्चन है व्हाट इज द एक्सेलरेशन ड्यू टू ग्रेविटी। सिंपल अगेन डेफिनेशन इज दैट the constant acceleration produced in the freely falling body to the Earth's gravitational pull. Gravitational force means what? Just Earth pulls any object towards the center. This is the gravitational force, and we based on that pulling or pushing of the object means what? Force is there. So acceleration due to gravity. Acceleration we based on that acceleration, but this acceleration happened due to the gravitational force. So this is the acceleration due to gravity. Definition is that the constant acceleration is that produced in a freely falling body to the earth gravitation force. Constant acceleration there. Again, underline this point, important point. Constant acceleration. When we consider the gravitational force, otherwise gravity is that gravitational force of the earth, that means this is the constant acceleration in there. Okay, because we well know that the gravitational force is 9.8 meter per second square. In overall Earth, we approximately consider 9.8 meter per second square is there. Okay, this is the gravitational force. Again, next question, we have seen the relation between the acceleration due to gravity and universal constant. Okay, these are two things are there. Small g is the acceleration due to gravity, and capital G is the universal constant is there. Let's see what is the relation. These are the expression is already completed. Expression we are starting from the according to the universal law of gravitation constant. This is according to the Newton's law statement, that is m is equal to g m divided by r square is that. Again in this equation, what is the capital M? Capital M is the mass of the earth, small m is the mass of the object, and r is the radius of the earth. When your object on the Earth's surface, otherwise object increases to the Earth's surface, okay, above the Earth's surface means circumference of the Earth. Okay, that times we consider the force is equal to G m by R square. Again, we know that force is equal to mass into gravity there, because we have the formula force is equal to mass into acceleration. But your object just falling on the Earth's surface, that time acceleration becomes the acceleration due to gravity. Means we consider force is equal to m into g. And according to this equation, this is the first equation, this is the second equation. From first and second equation, mg is equal to capital G m divided by r square is the capital M is there. If m gets cancelled, small m is cancelled, and g is equal to g m divided by r square is there. So this is the relation between the small g and capital G. Okay. Here g is the acceleration due to gravity, m is the mass of the Earth, capital G is the universal gravitation constant, r is the radius of Earth, and along with the relation, this equation shows that acceleration due to gravity on the Earth's surface does not depend upon mass of the body. Means this acceleration due to gravity, small g, does not depend upon mass of the body. Again, this is important point. This will be definitely this will ask in your examination in objective type question. Small g is does not depends on. Options are there. Capital G, capital M, small m, capital R. So answer is the small m, because small m means mass of the object. So small g, acceleration due to gravity is does not depend upon mass of the object. Okay, so acceleration due to gravity depends on capital G, but here capital G is always constant. Okay. Again, here mass of the Earth means again this is mass of the Earth is here. When we change our planet, that time small g also changes here, and also depend upon the radius of that object. Okay. So here this is the relation, and acceleration, the value of acceleration due to gravity is what here 9.8 meter per second square. This is the acceleration due to gravity. Okay, yes, Sumit.
Hello, sir.
Yes.
So the freely falling body travels equal distance in equal time
Equal distance
in equal unit time.
No, beta, equal not distance, because that acceleration is there, change in velocity, is change in displacement with respect to time is there. So equal distance not is equal distance. When the object is freely falling, then velocity will be increases there.
Sir, why the
increases.
velocity increases, sir?
Yes.
Why the velocity of object increases?
Because gravitation pull is there, force applied on this object, so velocity changes here.
Sir? Sir, during the free fall, the acceleration is constant?
Acceleration is constant here.
Okay, sir.
Free fall acceleration due to gravity is constant.
Okay.
Yes, Suyesh.
Hello, sir.
Yes, बहुत दिनों बाद पूछ रहा है बाबा, बोल।
Sir, can we consider acceleration due to gravity as 10 meter per second square?
You can consider here, but generally, if value of the acceleration due to gravity in given problems, that is 10 meter per second, means example में दिया जाता है, take small g is 10 meter per second square. That time you consider 10 meter per second square. Otherwise, you can consider 9.8 meter per second square. अगर नहीं दी वैल्यू तो 9.8 ही कंसीडर करना है। अगेन वन मोर थिंग, ऑब्जेक्टिव टाइप क्वेश्चन में आपको फर्स्ट कैलकुलेशन, अगर सपोज g की वैल्यू नहीं दी तो एक और एक बात बोलता हूं, इंपॉर्टेंट है, इफ द वैल्यू इज नॉट गिवन इन देयर प्रॉब्लम, तो मैंने तो कहा कि 9.8 लिखना है, लेकिन अगर ऑब्जेक्टिव टाइप क्वेश्चन है तो फर्स्ट आप स्मॉल g 10 मीटर पर सेकंड से कैलकुलेट करो, उसके बाद अगर आंसर में कुछ डिफरेंस आ रहा है तो 9.8 से कैलकुलेट करो, क्योंकि जनरली ऑब्जेक्टिव टाइप क्वेश्चन में क्या होता है, वो 10 मीटर पर सेकंड स्क्वायर कंसीडर करके वैल्यू देते हैं, तो दैट टाइम यू कंसीडर द 10 मीटर पर सेकंड स्क्वायर।
Okay.
ये सब होगा।
So the small g, that is acceleration due to gravity, is dependent on what?
dependent on the this mass of the earth, again mass of the object, mass of the planet also. Again the radius of the earth or radius of the planet. Okay,
Yes, sir.
Shweta.
Sir, please once again repeat this relation between G.
G, this mathematical expression.
Huh.
First, according to this is according to the Newton's law. It is according to Newton's law. Newton's law, force is equal to capital G m divided by r square. Capital M means what? Mass of the planet. Small m means mass of the object. Means like that. Suppose this is on Earth surface, and here one object. Okay, just free fall on Earth surface. Okay, that position. This is the small m, and this is the capital M is there. And again, capital R means this is the radius of the Earth. That time we consider force is equal to G mm divided by R square. Equation 1 here. Again, this is according to the Newton's second law of motion. Okay, Newton's second law of motion. What is the Newton's second law of motion? Force is equal to mass into acceleration. Okay, force into mass into acceleration. Actually, equation is force is equal to mass into acceleration. But here acceleration means acceleration is the acceleration due to gravity. Why? Because the object is falling on the Earth surface. So we can write here small g instead of the a. So F is equal to m into g. And from equation 1 and 2, equation 1 and 2, LHS are same. And right RHS also same here. Mg is equal to gmm by r square. Mm gets cancelled because same values here. So we get g is equal to gm by r square. This is the relation. Okay, Shweta? Okay. Yes, part.
Sir, 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 that when body comes towards the earth, the velocity increases in free fall, but the acceleration is constant. How, sir?
Change in velocity with respect to time. Difference, the velocity is constant here. Initial, final. Okay, first initial velocity and then final velocity. हर एक position में we consider the constant. Suppose this is object position, first A position. Again, this is the B, C, and D position. A to B. When we consider where object is falling from A to B position, it's having some velocity there. Means B is again this is the difference between the final to initial position. Again, we change the position from B to C. Again, we find the final position. This velocity is there. Again, this is V1, this is V2. All time the velocity is constant here. Means जो difference है ना वो constant रहता है. Difference, there is a change in velocity with respect to time. ये जो value जो मिलते हैं ना हमें वो constant मिलेगा हमें हर वक्त. इसलिए हम उसे acceleration constant कहते हैं. क्योंकि change in velocity with respect to time में कैसे constantly change हो रहा है. So that time acceleration is constant here. Pranav.
सर वो एक बार स्टेटमेंट रिपीट करो ना वो जी डिपेंड्स ऑन
G, first G is independent on mass of the object. एक important. अब depend किसके ऊपर है? G is depends upon the mass of the planet and depends upon radius of the planet. Actually, now suppose we change the planet, so obviously mass of the planet will be changed, radius of the planet will be changed. So both are changed. Obviously, small g is also changed here.
यस सर
सर अगर फ्री फॉल ऑब्जेक्ट पर ग्रेविटेशन फोर्स के अलावा और कौन सा फोर्स लगता होगा तो उसका एक्सेलरेशन 10 ही रहेगा या और कुछ उसमें चेंज आएगा?
दूसरा फोर्स आप लगा रहे हैं मतलब
हाँ
जस्ट उसे फ्री फॉल नहीं कहेंगे। अगर दूसरा
हाँ
फोर्स अगर लगा रहे तो दिस इज नॉट कॉल्ड एज फ्री फॉल, तो फ्री फॉल नहीं होगा क्योंकि आप अदर फोर्स भी एक्ट कर रहे हैं वहां पर, तो फ्री फॉल कहां से होगा? फ्री फॉल
yes
मतलब क्या, फ्रीली वो नीचे आ रहा है ओनली ड्यू टू द ग्रेविटेशन फोर्स, तो वो फ्री फॉल नहीं होगा। अगर मैंने ऑब्जेक्ट और ऐसे जोर से नीचे फेंक दिया तो मैं भी फोर्स लगा रहा हूँ, ग्रेविटेशन फोर्स लगा रहा है, दिस व्हेन इज नॉट अ फ्री फॉल, तो ये फ्री फॉल नहीं
तो
होगा।
उसको कैसे निकालने का?
दैट टाइम फोर्स आपको वो देगा, अप्लाइड फोर्स एंड ग्रेविटेशन फोर्स,
Okay.
means we adding both. Suppose same direction is there, applied force and gravitation force. Okay, gravitation force and applied force same direction, then we have to addition both forces. And suppose an object throwing upward direction. Again, this is the opposite direction. Applied force and gravitation force both are opposite direction. And that time you consider the negative sign is there.
Okay sir.
Yes, Rudra. That's okay. आप पूछोगे क्या? हाँ.
सर एक बार बताओ ना, एक्सेलरेशन और वेलोसिटी वो आपने बोला ना कांस्टेंट रहता है कौन सा? तो
आप देखो यहाँ पे इस कंडीशन है कि एक्सेलरेशन ड्यू टू ग्रेविटी में एक्सेलरेशन कांस्टेंट रहता है। ओके, व्हेन वी कंसीडर द एक्सेलरेशन ड्यू टू ग्रेविटी, फार्मूला क्या है हमारे पास? एक्सेलरेशन इज इक्वल टू चेंज इन वेलोसिटी विद रिस्पेक्ट टू टाइम। acceleration is equal to change in velocity with respect to time. Okay, v minus u divided by t is there. अगर आप object you are freely falling on object is freely falling, that time means final velocity is there, initial velocity is there. Object first point से आ रहा है, initial velocity होगी a position, okay, a से b position पे आ रहा है, and this is having the final velocity. Okay? Again, this is v, this is u, this is v. And we have to find the acceleration here. V minus u is the acceleration. Yes. Yes, Rudra. Let's see. Again, B to C. Again, this is the position. These are the positions. These are positions. A, B, C is there.
त्यात सरांचा फोन आलता हो.
Let's see. A to B, B to C. Initial velocity, final velocity. Again, if you find the B to C, again this will consider here the initial velocity and this is the final velocity is there. And when you find alpha's position, acceleration is there, again this acceleration is there. At that time, change in velocity with respect to time. ये जो handle आपको जो मिलेगा ना, ये always constant रहेगा. एक ही वैल्यू. Suppose initial यहाँ पे final velocity है, suppose 20 meter per second, initial velocity 10 meter per second. And again time suppose 5 seconds is there. So acceleration becomes 20 minus 10 divided by 5, means 10 by 5 is equal to 2 is there. Okay, 2 meter per second square. Again B to C. B to C, suppose velocity V increases, means here V is the 20 meter per second and initial velocity is the, देखो थोड़ा सा कंफ्यूज होता है यहाँ पे. फर्स्ट ये इनिशियल वेलोसिटी है, u इनिशियल वेलोसिटी, फाइनल वेलोसिटी. इनिशियल वेलोसिटी जब आप एक टॉप पे कांस्टेंट वैल्यू कंसीडर करें तब वहां पे आपका इनिशियल वेलोसिटी क्या होगा? 0 मीटर पर सेकंड. ओके, क्योंकि यहां से हम रिलीज कर रहे थे. देन फाइनल वेलोसिटी, अगेन फाइनल वेलोसिटी सपोज द 20 मीटर पर सेकंड. So this is the acceleration becomes in the 20 minus 0 divided by in time. Suppose time is there the 5 seconds. Time always हमें constant रखना है. T is equal to 5 seconds. Okay. This is the T. This is the T is there. Initial velocity 0 meter per second. We have final velocity 20 meter per second. Acceleration becomes 20 minus 0 divided by 5. This is a 4 meter per second square. Okay, again next position. When the object from starting from B to C position. Now at that position, B is the initial velocity. करेक्ट है ना। अब यहाँ पे इनिशियल वेलोसिटी, अब यहाँ पे बी पोजीशन पे फाइनल दिया था, तो व्हेन योर ऑब्जेक्ट फॉलिंग फ्रॉम ए टू बी पोजीशन, नाउ वी हैव टू कंसीडर हियर ऑब्जेक्ट यू आर फॉलिंग फ्रॉम बी टू सी, that time again b is the initial position, so this is the initial velocity is there, so again here we consider the initial velocity 20 meter per second, and here final velocity again when we calculate after time t, means time is the 5 second, after 5 second we get the final velocity here the 60 meter per second। जब हम कैलकुलेट करेंगे तब हमें ये वेलोसिटी मिलेगी, that time the velocity is 60 meter per second। So again when we calculate the acceleration, then 60 minus 20 divided by 5, again it becomes 620, आंसर आपका 4 आना चाहिए। मींस यहाँ पे आपको क्या देना होगा, 40 देना होगा, यहाँ 40 दे दो, 20 by 5 यहाँ पे 40 देना है, ये कांस्टेंट आता है। 40 minus 20, 20 by 5, again this is the 4 meter per second। okay, तो इस टाइम में आपको वेलोसिटी उतने, दैट इज द आफ्टर टाइम की आपको वेलोसिटी इतनी मिलती है, कांस्टेंट पे इतनी वेलोसिटी इसी यूनिफॉर्म मिलती है। yes वैभव नहीं डाउट।
Sir, that on how did Newton guess the inverse square rule? That topic is given. In it, the formulas are going to come. That some equations are given at last.
Which equations?
Sir, v square is directly proportional to 1 by r into r cube upon t square.
This is the Kepler's law. T square directly proportional to the r cube. This is from Kepler's law.
Sir, so they are going to come?
Again, this is having the mathematical expression like the inverse square law. According to inverse square law, again Newton solved this inverse square law. From the inverse square law, he derived the Newton's his universal law of constant. Okay. Again, inverse square law, we derive this is again inverse square law is f is inversely proportional to the r square. Again, this equation we derive from the centripetal force. Again, some Kepler's third law, and then we derive the f is inversely proportional to the r square. Similarly, also here t square is proportional to the r cube. So there is the t square, it is proportional to the r cube, means t square is equal to k r cube is there. Otherwise, you can also rearrange this equation. Means also you can write r cube is equal to k t square is there. Means k is equal to r cube divided by t square is there. This is again a mathematical expression. So derivation and integrations is there. This is not for you in your class. This is derivation or integration. At that position, they calculated these equations.
Sir, so this is not coming in exam, Kepler's law.
Only statement is there. Statement and equation, particular square law. Statement important, but Kepler's first law is there, second law is there, and also Kepler's first law is also known as, Kepler's second law is also known as, Kepler's third law is also known as. This is important here. So this point is okay.
Yes, sir.
Now let's continue. This is the already given to you. This is the motion of object under the influence of gravitational force. हाँ स्टूडेंट उसने हैंड रेज किया, मैं उनके पास आऊँगा. But completed this equation. This is the left side. General equations of motions are there. This is the Newton's equation of motion. First equation of motion, second equation of motion, and third equation of motion. Again, these are the V is equal to U plus A, S is equal to U plus half, A square, B square is equal to U square plus 2S. This is the equation. in this general equation, V is the final velocity, U is the initial velocity, A is the acceleration, T is the time is there. Again, S is the distance or displacement is there, and one more thing is T again, T is time is there. So these are the general equation. But when your object just freely fall, that position, equation of motion will be changed. So what will be changed? Only the motion of